Hello, dear students. Hope you are doing good. So, welcome back in this series of CBSE Class 10 Physics. Now, we are going to see a very important topic from the chapter Electricity, and this topic is series and parallel combinations of the resistor. You might have learned all the basic concept of electricity earlier, like charge, current, potential difference, Ohm's law. Now we are going to see a very special these topics. Let us understand this thing by the comparison. So that's why I have written the two columns here. So let us first understand what basically is a series combination of the resistor and parallel combination of resistors. So series combination is that said to be the combination when two resistors are connected with just one single common point. That means after a one resistor, suppose this is resistor R1, there is a resistance R2. Its start is connected. That means between R1 and R2 there is only single common point. Suppose there is again third one resistance is there. Let us that third resistors be R3. So between R2 and R3 there is a single common point. So in this way, if the arrangement is there, then that arrangement is called as a series combination of resistors. And what happens in parallel combination? Suppose there are three resistance we again consider as R1, R2 and R3 resistance, and all the resistors ends are connected at common point like this. Then such combination of resistor is called as a parallel combination of resistor. So here between R1 and R2 there are two common points. R2 and R3 there is again two common points. If more than one common point is there, then that combination is said to be a parallel combination. You can compare this arrangement like passing of water in a tube. Suppose there is a tube and some obstacle is there, then two obstacles are there smoothly. Suppose this is the first obstacle in the water tube and the another obstacle is like this. The amount of water flowing through the first obstacle will be the same as the amount of water flowing through the other obstacle. That means here, if we compare this with the current flow in the circuit, that means the second difference comes here in the series combination, that current flowing through it will be the same. Current across each resistor will be same. And if we consider the same analogy in the parallel combination, in parallel combination, if suppose there is a junction is getting formed like this, suppose there is a junction, then there is a splitting of amount of current and there is a resistor or obstacle across the tube. So across the each resistor or obstacle, the amount of water flowing each obstacle will be different. So in this way we can say that the obstacles here, if they are different, that means if they are parallel, the different amount of flow is there. So in parallel combination of the resistor, the current will be different. So we can plot this, we can consider this as a second point of difference. So therefore we can write it here, or we can just compare the series combination and parallel combination of the resistor by just by seeing it. Current in series combination is same, current I is same in each resistor. But here in parallel combination, current through each resistor will be different. Will be different. And you can consider this as a criteria for identifying the complex circuits, whether the resistors are connected in series or parallel. Suppose if the current passing through it is is the same, then those resistors are considered to be parallel and sorry series. If the current passing through each resistor, if it is different, then those resistor will be connected in parallel. So here let that current will be I1 passing through R1, I2 passing through R2, and I3 is the current passing through R3. Now let us consider the another point of potential difference. Here potential difference across each resistor, potential difference across each resistor will be different. And here, but potential difference will be same across each resistor, because here the point, if you connect the voltmeter across here between the 2 points, the potential difference will be the same. But if you connect a voltmeter across each resistor, the voltmeter will show the different reading. So here in parallel combination, the potential difference is same across each resistor. So remember these 2 points to identify in circuit. If the resistor are connected in series, the potential difference will be different, but current is same. And in parallel combination, current is different and potential difference is same. So these are the important points. And finally, the total resistance of the circuit, if they are connected in series, so total resistance considered to be Rs, then it will be R1 plus R2 plus R3. And if the circuit is in parallel, then effective resistance, if Rp total resistance, then total resistance will be 1 upon R1 plus 1 upon R2 plus 1 upon R3. We can make another difference between these two. In series resistors, the effective resistance increases, so that we can say that Rs value will be individually greater than R1, Rs is greater than R2, and Rs is greater than R3 also. But here the effective resistance value in parallel circuit, it decreases. So Rp is less than R1, Rp is less than R2, and Rp is also less than individually R3.